everyone. Today we came up with our new topic as morphine. In this part of the video, we will concentrate over the name of the morphine and receptors over where it acts and where it is located. And moreover, the most important part is the SAR or structure activity relationship of morphine. That is the most important part of the morphine for which the activity can be increased or can be reduced or the metabolism can be affected and overall. So let us concentrate over the morphine. The opioid drugs are basically being termed as morphine. They produce a pharmacological action including analgesia by acting on the receptors located on the neuronal cell membranes. The morphine, it is named basically after the Greek god Morpheus, god of dream, good for treating dull, constant pain rather than short, periodic pain. It has a side effect of excitation, euphoria, nausea, pupil constriction, constipation, tolerance and dependence, depression and breathing. So we can see here the structure. We have named it and number it also 1, 2, 3, 4. We have seen that at the 3 position it is an alcohol, at the 6 position it is an alcohol, it is an lactone bridge over the 5 and 4 position with the oxygen. And moreover, another important part is a double bond at the 7 and 8 position. 14 there is an hydrogen. We have given the stereochemical structure here. Here another part is the NCH3 part, which is here at the 17th position. We will just focus over these things over the morphine. We will just focus here over the 2 types of SAR which have been concentrated over one. First, the receptors over where the morphine can be act. They are basically termed as 3 receptors. There is opioid receptors which are known as mu, kappa and delta. The mu has been located in the brain spinal cord. Affect analgesia, respiratory depression, euphoria, addiction. All pain masses have been blocked. The kappa has been basically located in the brain and spinal cord. Analgesia, sedation, all non-thermal pain masses blocked. And the delta has been basically located over the brain only, not in the spinal cord. It basically affects on the analgesia and the dependence. So basically we take over the morphine. It gets bind with the mu opioid receptor and corresponding to the GABA is being converted to the GABA receptor and corresponding the dopamine has been secreted or released and act over the dopamine receptor and gives the basic activity. Now let's see together the effect of the marxing or removal. If we remove the phenyl moiety at the first benzene ring, it basically decreases the activity. If we convert the R, that is a OH, if we convert it with methyl group, the compound which is being forming is a codeine. Codeine is 20% active, injected peripherally. It basically converted to morphine only to produce the effect. The 6th position alcohol, which is also very important. Activity increases due to reduced polarity. Compounds can cross the blood-brain barrier very easily. 6th OH is not very important for the binding position. Now let's focus over the R part of the acetomorphin. If we convert the OR, that is the 6th position OH, we converted the R with methyl acetyl group, then it has been called a 6-acetyl morphine. It can mark the polar alcohol group, make it easily to cross the blood-brain barrier, but the phenyl group is free and molecule can bind immediately. Dependence is high, but it has been banned in many countries. The double bond at the 7 and 8 position, basically the alkene group is not important to the binding. It also, the dihydrobondrin also shown increased activity. The 3rd degree amine is very essential to binding. If we convert it with any other part, then the activity basically reduces. If we convert the NR with NH, then it will be converted to normorphine with reduced activity or no act. If we convert the NR to N-methyl 2, then no activity has been shown. Normorphine is more polar and cross the blood-brain barrier. The R effect with the analog is an antagonist, and rigidation could be applied to stabilize such conformation. Optimum distance between third degree amine and phenyl ring is very essential for the activity. This point is very important, that the optical distance between the third degree amine and the phenyl ring is very essential for the overall activity. The important binding site I have given here. Just have a look over the slides which have been provided to you. The phenol, again I have been concentrating on the SAR. The first is the phenol part. The code is easily being metabolized. So I have told you in the previously, the activity basically shown by codeine is due to the morphine, but weaker analgesic and weaker side effect. Marxing phenol is for bad for the activity. Now basically acetyl marks a polar phenol group. Compounds can easily cross the blood-brain barrier. Acetyl group is hydrolyzed in brain to form morphine. So basically we can see that if we change the alcohol group with any other position, it basically metabolizes to morphine only to produce its effect. Then the 6th alcohol position is very important. It basically increases due to reduced polarity. Activity basically increases the morphine, hydromorphone and disorphine. This is the 3 compounds we can see. Oxidation coupled with reduction at 7-8 position increases activity. The 6th position alcohol, the heterocodeine can be, which has 5x activity than that of the morphine. If we convert it with 6-acetyl morphine, it also can increase the activity we have told earlier. The double bond is a dihydromorphine. It's also been showing that it can be able to increase the activity. A stereochemical factor, that metabolism morphine has no activity, and the other structure, that is a stereochemical structure, is being shown that it has been reducing 10% activity of that of the morphine. The 6th position alcohol and the phenol is very important. If the R group has been converted to the acetyl group, the compound which you get is a heroin, which is increased solubility. Heroin can cross the blood-brain barrier very easily. The acetyl group is hydrolyzed into the brain to generate morphine. Fast onset of action and intense euphoric effect. So heroin has been banned in many countries, and moreover it is considered to be as a narcotic drug also. The nitrogen is very important for the activity. Depletion of NCH3. If morphine also a methyl group attached with the nitrogen, if the methyl group is replaced by the propynyl group, an antagonist of morphine has been formed called the nalorphine has been basically formed. And moreover, the summary of the structure activity relationship, that is certain things which I have focused over the last part of the video, has been concentrated here. Thank you.